Nothing in this section should be new. It's just taking the material that we've already covered and presenting it in a new way. When we say the term compound or a compound figure, that means a figure that's made up of more than one piece. So if we're looking at our first example, which is here, this compound figure means that we have two separate rectangles that are built together. Now you could break this rectangle up by creating a line here or by creating a line here, and you'll get the same answer both ways. I'm going to draw a line over this way, but the other way would be just fine. Now the idea is I want to find these new rectangles that I created and find their area and then add them together. So for this bottom one, this is a base of 10 and a height of 2, so therefore the area is 20 square centimeters. That one's not too bad. But this top one, it's a little bit tricky. We need to figure out what this length is here. Well, I know that this whole length on the bottom is 10, and this length here is 6. Therefore, this has to be 4, because 4 plus 6 has to be equal to 10 on the bottom. And with the same idea, this whole length here is 9, and this length here is 2. Therefore, this has to be 7, because 7 plus 2 equals 9. Now we can put the labels on these, and then we solve. 4 times 7 is 28 centimeters. Now, the area of these two figures together makes the area of the entire figure. So we go 28 plus 20 is equal to 48 square centimeters for this rectangle. Okay, and so the shapes will get bigger and more difficult, but the idea is the same. If you have a compound figure, you break it up into smaller pieces, find the area of each, and then add them all up at the end. So getting a little bit tougher here. This one we're going to have to break up into 3 pieces at least. You could break it up into more, but I think 3 is the easiest way. So we'll draw a line there and a line there. Now this square actually is pretty easy. That's 2 times 2, which is 4 feet squared. Now this one down here is going to be a little bit tougher. If this length here is 2 and this length here is 3 and the whole length is 7, 2 plus 2 plus 3 is 7, so that's bottom is 2. And the height here is going to be, now this is a little bit tougher, but this here is 3, but we have a little bit extra. So I noticed that this is 2 and this is 2, so the entire height is 4. So this would be 8 feet squared. And the last one here, that one's pretty much already drawn, and that's a 3 by 3, so that's 9 feet squared. So then we add up the 3 pieces, 4 plus 8 plus 9, which is 21 square feet. Okay? So there's one more type of example we're going to do before I'll give you a problem for candy. Is this one here, if we have a square inside a square. So the idea of this problem is if we take this red square and we pull it out, we have a green square and a red square. But since we have it inside this piece, we want to know what the green area is. But if we do 12 times 6, that ends up being 72 feet for the entire outside box. So that's this. 12 times 6 is this entire green area. But this red is taking away some of the green area. So then we have to find the red, which is 8 times 4, which is 32 square feet. And then the new green area would be the green minus the red, which is 40 square feet. So the idea here is that to find this green piece on the outside, we have to take the whole outside box, subtracting the inside piece, and that will give us our answer here of 40 square feet. So for this example, we did the big rectangle minus the little one. Now, for a problem that you can do for candy, I want you to find the yellow area. So this one, like the other one, you have to find the whole outside piece, and then you're going to subtract the inner two rectangles. When you're done, you can bring that to me, and if you got it correct, I will give you a piece of candy.